Okay, let's talk about the percentages on the bell curve here. This symbol right here is representative of the mean. It's the Greek letter mu, M-U, and it's like a U with a tail. This is the sigma, meaning standard deviation, and we'll talk about what all this means in a minute when we talk about z-scores as well. But right now I just want to try to explain why the 68, the 95, the 99. Okay, so here we go. Let's look back at the pictures I had before on the previous video and just get some pictures of some histograms. Remember that a histogram is basically just a visual representation of how often any particular data point shows up. In this particular example, the same data set's being used, but they're chopping it up into different groups, so there's more and more bars. Okay, and remember that the height of the bar is representative of how many data points fell within that particular group. So if we look at our Olympic data, remember that our mode was 24. So that means our most frequently occurring age was 24. So that is the height of the highest bar right here. And it looks like it was over 2,000 people had ages between 24 and 26. Okay, so what's going on with the percentages is, as a general rule, and this is where we're probably going to be talking more for future classes, but as a general rule, if you think of the area underneath this curve, all this is brownish gold color under here, 100% of the area is under the curve. Okay. If you go one standard deviation to the right and one standard deviation to the left from the center where your mean is in a perfect world, then you should expect 34 and 34, 68% of the area. In other words, 68% of your data should be occurring between those two. More than half of your data will occur between those 2 points. Again, if we look at the Olympic data, I don't have this divided up in standard deviations, but I'm going to talk about that in the next video. Remember that our standard deviation was around 5, which means that we would expect, now again, this bar does not represent the 68%, but we would expect more than half of our data, 68% of our data, to be between 31 and 21, 5 above, 5 below, and I will talk more about that in the next video. But that's where the percentages are coming from. That's a theoretical percentage that in a perfect world that would work. And then you would expect 95% of your data to be within 2 standard deviations, and almost everything should be, in a perfect world, 99.7% within 3 standard deviations. So whenever we start talking about this whole idea of this is 1 standard deviation, 2, 3, I'll talk more about that in a minute, but when we use that test to test for outliers, when something is more than 3 standard deviations, your percentage of your data realistically is so small that it's just unlikely for that to be outside of that area. So you have to have a good reason for including that data to still call your distribution normal. Okay, and remember in the previous video, you can have a slightly normal distribution, but it could be skewed, okay, left or to the right. Hopefully that helps with the percentages part. The standard deviations coming next.